I am back with a video on crash course on physical world. क्लास 11th के फिजिक्स का शुभारंभ होने वाला है और हमेशा की तरह whenever we start the new course, the first question is about what is science, what is physics, what is chemistry, and that's how we have been studying since class 5 or class 6. So once again, let us define what is physics. So physics, as we all know, is the study of nature and natural phenomenon. रेनबो कैसे होती है, स्काई का कलर ब्लू क्यों होता है, व्हाई डू स्टार्स ट्विंकल, पेड़ से एप्पल हमेशा नीचे ही क्यों गिरता है. तो इस तरह की जितनी भी नेचुरल फेनोमेनन हमारे आसपास होती है उनके पीछे का साइंस हम पढ़ते हैं थ्रू फिजिक्स. As scientists research and try to explore the physics behind all the natural phenomena, they follow a process. This is what we call as the scientific method. The scientific method has 5 interconnected steps. Step number 1, systematic observation. अगर हम बात करें फेमस साइंटिस्ट सर न्यूटन की, जिन्होंने यूनिवर्सल लॉ ऑफ ग्रेविटेशन दिया था, तो उन्होंने कीनली ऑब्जर्व किया था दैट द एप्पल फेल डाउन द ट्री टू द ग्राउंड. तो ये उनका कीन ऑब्जर्वेशन था. सो एवरीथिंग स्टार्ट्स विथ ऑब्जर्वेशन. स्टेप 2, कंट्रोल्ड एक्सपेरिमेंट्स. Because any incident that you notice or see for the first time, that could have happened just by chance. So it is important that we perform a series of experiments just to ensure that this phenomenon keep happening the same way. Step number 3, qualitative and quantitative reasoning. It is also important that we also validate this entire experiment with valid as well as invalid data. क्या काम करता है, कौन सी चीजें काम नहीं करती है, इन सारे हर तरह के डेटा के साथ इसे वैलिडेट करना है. स्टेप 4, मैथमेटिकल मॉडलिंग. अगर हम देखें, जब यूनिवर्सल लॉ ऑफ ग्रेविटेशन आया उससे पहले उसका एक मैथमेटिकल फॉर्म ऑफ रिप्रेजेंटेशन आया. फाइनली द लास्ट स्टेप, वेरिफिकेशन एंड फॉल्सिफिकेशन ऑफ थ्योरीज. Now it is very important that we do that final round of verification to ensure that this law holds true universally for all the objects at all the places. For example, this Newton's law of gravitation again was verified well enough and then only put forward as a law. However, several years later, when Einstein's theory of relativity came into picture, it in a way questioned Newton's law of gravitation. Physics और technology में एक गहरा connection सा है. At certain times, physics gives rise to technology, whereas at other times, technology gives rise to physics. Surprised? Let's look at examples. Let's talk about the computers, जो कि we see all over these days. So it's almost like a computer age. So computers are technology, right? So, but from where did we get these computers? From the silicon chip, the integrated circuits. And what was that? That was physics. So this is an example where we see physics gave rise to technology. Now let's look at another example where technology gave rise to physics. Let's talk about the heat engine, which came first, and then from the heat engine came the entire theory and concepts of thermodynamics which we study in physics. So that's an example of technology giving rise to physics. So we saw that physics and technology has a strong bond. Now when we talk about physics or nature or natural phenomena, there is one critical thing that plays a very crucial role, and that is force. Now we have all learnt about forces in our junior classes. And here in this video, we are not getting into the detail of these forces, but what we will do is, we will get a quick understanding of the forces which naturally exist, like they are there in nature. So we will learn about these type of forces. Now even before we talk about these types of forces, let's do a quick recap on force. What is force? A push or pull that can cause an object change its velocity or change its shape. Let's look at this ball. It's spherical in shape. Now the moment I apply a lot of pressure in it, the shape kind of changes. Ball पिचक सा गया है, right? So there's a change in shape. Looking at the ball again, it's at rest right now. But the moment I apply a force on it, its velocity would change. There are two types of forces, fundamental force and derived force. Now, fundamental forces are those forces which naturally exist. So they exist in nature on their own. And there are 4 types of fundamental forces. Gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Now coming back to the derived forces, these are the forces which are derived from the fundamental forces in some or the other way. So if we think of examples of derived forces, all other forces that we talk about, whether it is the spring force, muscular force, friction, they all come under this category of derived forces. So in this video, as I had earlier mentioned, we are just going to focus on the forces that exist naturally. That is, these 4 types of fundamental forces. Gravitational force. Gravitation word से ही हमें याद आता है apple and the tree. Apple पेड़ से नीचे गिरा. So that has kind of become the view of gravitational force. So this gravitational force is a universal force, not just the apple and the tree. It exists between any 2 objects. If we talk about the nature of this force, it is a mutually attractive force. The magnitude of this force depends upon the masses of these two bodies and also the distance between them. अगर दोनों ऑब्जेक्ट के बीच का डिस्टेंस बहुत ज्यादा है तो ग्रेविटेशनल फोर्स कम होगा, और अगर इनका डिस्टेंस कम है तो ग्रेविटेशनल फोर्स ज्यादा होगा. There is no medium required for this force, and gravitational force is the weakest of all the forces. In fact, the moon moving around the earth is also an example of the gravitational force. Had there been no gravitational force, in that case the moon would have not been moving around the earth and would have fallen back somewhere. Electromagnetic force. नाम से ही लग रहा है कुछ तो इलेक्ट्रिक, मैग्नेटिक कुछ तो है. This force is all about charges. So this force exists between charged particles. तो अब चार्ज्ड पार्टिकल्स पॉजिटिवली चार्ज भी हो सकते हैं, नेगेटिवली चार्ज भी हो सकते हैं, विच इन अ वे टेल्स अस कि ये जो फोर्स है ये अट्रैक्टिव भी हो सकता है और रिपल्सिव भी हो सकता है, क्योंकि अगर ये फोर्स दो लाइक चार्जेस के बीच में होगा तो रिपल्सिव होगा, अगर दो अनलाइक चार्जेस के बीच में होगा तो अट्रैक्टिव होगा. Again, this force also doesn't need any medium, and this force is 10 to the power 38 times stronger than the gravitational force. तो gravitational force से तो ये बहुत 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 ज़्यादा strong force है. अब बारी है strong nuclear force की. Force के नाम में ही strong है. क्यों? क्योंकि this is the strongest force. Force के नाम में nuclear भी है. क्यों? Because this force exists within the nucleus. अगर विद इन द न्यूक्लियस है तो ये फोर्स किसके बीच में होगा? न्यूक्लियस के अंदर कौन होता है? न्यूक्लियस के अंदर होता है प्रोटॉन्स एंड न्यूट्रॉन्स. प्रोटॉन्स जो कि पॉजिटिवली चार्ज्ड है एंड न्यूट्रॉन्स जिनमें कोई चार्ज नहीं होता है. तो इसका ये भी मतलब है कि इस तरह का जो फोर्स है दिस इज इंडिपेंडेंट ऑफ चार्ज. इट डजंट मैटर वेदर इट इज पॉजिटिवली और नेगेटिवली और न्यूट्रल. It is charged independent force, and this is the strongest of all force. Finally, the fourth one, that is weak nuclear force. So this is also a nuclear force, so this also exists within the nucleus, but this is a very weak force, and this force comes into picture when we talk about the phenomenon of radioactive decay. We have learned about radioactivity. If we haven't, we are going to learn about it very soon. So radioactivity is a phenomenon which takes place only in heavy nuclei, where we see that a particular nucleus emits an alpha particle or a beta particle. So I'm not getting into the detail of that, but this entire phenomenon of radioactivity takes place, and there this weak nuclear force plays a role, but this is a weak force. So we have learned about the four types of fundamental forces so far. Now if I ask you, out of these four forces, there are two forces which operate over very short distances. Can you guess which are those two forces? Quite simple. There are two forces which operate within the nucleus, strong nuclear force and weak nuclear force. Now nucleus is a very short range thing, right? And that is why these two types of forces are also termed as short range forces. On the other hand, if we talk about the gravitational force or the electromagnetic force, they operate over larger distances, and therefore they are also termed as the long range forces.